Hello, welcome to this video. Over here we'll be doing the location of chloroplast pigments, the arrangement of those pigments, and the effect of these pigments on absorption spectra. So there are three things. The first thing is we're supposed to mention the chloroplast pigments. So we know that we have two types of pigments. They are primary pigments. Okay, maybe I can just use this text given by them, so I don't have to rewrite it. We have primary pigments, right? And then we have accessory pigments. There are two types of pigments. Okay. This is the first point you should be knowing. We have primary pigments and accessory pigments. And then under this primary we have chlorophyll A, and under accessory we have chlorophyll B, I forgot to give L here. Okay, we have chlorophyll B, okay, and also we have carotenoids. These are the pigments. So first, as we are supposed to give the arrangement and the location of chloroplast pigments, the first thing we are supposed to do is to mention the types. Okay, so we already mentioned the types. Now we start to mention their arrangement. Now these pigments are actually arranged in light harvesting clusters. These photosystems. Okay, we have this if you're familiar, maybe I can just find the so here we got the image for you. So normally these pigments we mention over here, they are normally found in thylakoid region over here. Okay, they are found in thylakoid region, and they form they are in photosystems. Okay, now if you want to understand, this photosystem is the one that was explained in photosynthesis process. Maybe I should find a picture of that too. So we got the image here. So these are the photosystems. Okay, they sort of enable the energy to go up. Okay, the ADP to change to ATP. Okay, and again another photosystem. Now there are two photosystems, as we say. There are photosystem 2 and there is photosystem 1. This is a P700, this is P60, P680. These are at different energy levels, and after reaching at this photosystem, it is where the ATPs are produced from ADP, right? Now actually here is when the ATP are broken down. These electrons are released from hydrogen to give us this to keep this chain going, right? So this is not our topic anyway. Let us get back to what we're supposed to know. I was just showing you the regions where P700 and P680 are. So these are the P, and these chlorophyll, these pigments are actually in the photosystem, in the thylakoids over here, this region here. Okay, these are the thylakoids. So they are found over here, and they are in the they're in P1 and P2 photosystems. Okay, now you should know that normally primary pigments are in the reaction center, and these accessory pigments surround primary pigments. Okay, so it's like this. If you wanna get it, this was the primary pigment, and then around here there are these all accessory pigments like chlorophyll B and carotenoids. Okay, so this yellow are carotenoids and what, and carotenoids and chlorophyll B. Okay, so chlorophyll B, and the red one which is inside, this is chlorophyll A. Okay, so hope that's clear. Then we go to the next thing, which tells you that light energy is absorbed by accessory pigments, carotenoids and chlorophyll B. They absorb the light energy, then energy passed on to primary pigments. So you should this is a part which may create a problem in understanding, that actually it's the chlorophyll B, this one is the chlorophyll B, and the carotenoids that absorb the light. Okay, these two are the ones that absorb the light, and after absorbing they convert it to energy, and then this energy goes to chlorophyll A, or in other words the reaction centers. Okay, it goes to the reaction centers. So so initially this is at chlorophyll A, this is in pigments, these pigments over here. So hope that was clear. And this is the point given here. These all points you're supposed to give to get the A marks, right? That the energy is passed to accessory pigments or carotenoids or chlorophyll B, then energy is passed on to primary pigments or chlorophyll A or reaction centers. These all are significant. Primary pigments, chlorophyll A, or any of these three will be fine to mention. Then we have chlorophyll A and B absorb light in red and blue violet regions. Now this, if you have done the absorption spectrum, you'll be familiar with this, that this both, there is even a question in absorption where this both, they take the light from the, these both have a graph like this. Okay, like let's say this is for chlorophyll A. Okay, and we say for chlorophyll B we have a graph which is similar to this, just a little difference, maybe like this. Okay, this is for A, this is for B. So this is for B, this was for A. Okay, so this for A, for B. Now this is they normally here, this is very low wavelength, around 500, no, around 400, around 300 actually, and here we have around 600. Okay, so in this region we have red color, and here we have blue, right? Blue or violet in the last region. Okay, so normally this chlorophyll A and B absorbs light in this region. However, carotenoids, they don't absorb light from the red region, they only absorb light from this region here, from this region, and here then they go down. Okay, these are the carotenoids. they absorb only in the violet blue region. They don't absorb in the red region. You should know that these are in nanometers. These are the wavelength. Okay, 600 wavelength. This is around 300 wavelength. Actually, it's not 300. We have the actual graph here. Excuse me. Yeah, here it's around 400. You see, it's not 300, and here it's around 700. So yeah, it's the same. I mean, the same concept. The wavelength sort of increases. Okay, and the same thing here is expressed. So all you need to know is that this graph have this kind of structure, right? So we have carotenoids absorb light in blue violet region. Then absorption spectrum peaks. We are supposed to be very careful with the peaks. Then we are supposed to even draw the absorption spectrum, and we have to different combination of pigments give different spectra. And we know that different combination of spectrum pigments will give different spectra. This all is fine, and hope now we will be familiar with the fact that we have to know even the action spectrum, where does it go, and as we said here, different combination of pigments will give different action spectrum. So for this case, we can have an action spectrum like going this way, but normally the action spectrum does not go this way. Action spectrum goes this way. It does incline here a bit, but then it has a slope. It does not have a flat surface over here like chlorophylls. Okay, so we had to mention three things. The arrangement, we say the arrangement was in the chloroplast, the carotenoids in outside, the chlorophyll inside, carotenoids and chlorophyll B outside, and then we came to mention the location of chloroplast pigments. So we also have to add to the things we already mentioned, that actually chlorophyll A is in reaction center inside. So these two normally just they're the same thing, arrangement and location. How are they arranged and how they are located? The arrangement is this is inside, that is outside. The location is in the thylakoid, and the reaction center is primary pigment chlorophyll A. So that's the idea behind this statement over here. And then we have the other statement which discusses the effect of absorption spectra. So absorption spectra, as we can see here, it's absorption spectra is this region here, right? Is this graph here, and we have discussed it very carefully. Hope you remember that this is B, okay, this is A, this graph over here is A, okay, and then there was this another graph coming up here which is action spectrum, and then there was this another red graph going this way which never comes up here. Remember that this does not have a high peak, the carotenoid absorption spectra, and that's all. And then if you are supposed to draw this, you should be very careful with the axis. There is wavelength against absorptions, okay, absorption or intensity, or whatever you want to keep it there. So that's the idea behind this. Hope it was helpful and it is clear. Thank you for listening, and hope to see you in the next video.